chapter 10.1 is about goodness of fit. And what's going to happen is you have a personnel director who believes that distributions of the reasons workers leave their jobs is different from the one shown in the graph. And what we mean by the graph is 41% in the graph showed that they left because they couldn't advance. 25% showed that it was lack of recognition. 15% showed low salary or benefits. 10% unhappy with management, and 9% were bored or they didn't know why they left. So the director randomly selected 200 workers who recently left their job and asked the reason why. And this was the data that he found. He found that 78 people left because of advancement, 52 left because of lack of recognition, 30 left because of low salary, 25 left because they were unhappy with the management, and 15 left because they were bored or they didn't know. We're going to look at this at alpha equal to 0.01 as our significance level. So the first thing we're going to do is identify the claim and state the null and alternative hypothesis. So the null hypothesis will be what the table says, and that's what they found out from the graph. The alternative hypothesis would be that the distribution of responses differs from the claim or the expected distribution. That's the claim that the personnel director is making. So the next thing you do is determine the critical value in the rejection region. So you're going to need the chi-square, and there are 5 sections. Here there's 1, 2, 3, 4, 5 answers. So 5 minus 1 would give me degrees of freedom equal to 4, and my alpha is 0.01. And the critical value, if you look it up in table 6 in the back of the book, the chi-square table, you'll find the critical value is 13.277, so your rejection region is greater than 13.277. So the calculator really doesn't help you with this problem, so we're not even going to look at it. You probably need to just do this by hand. So what we're going to do now is we're going to look at the table, but we're going to expand it. So the first column is the distribution. This is what you saw when you were when you looked at the table. This is what you found out with your data. This is what they've observed. And then you're going to take to get the expected value. This is how you do this one. For the expected value, you obtain it by multiplying 200, because there are 200 people that they surveyed, times 41%. 5% times 200 is 50. 15% times 200 is 30. 10% times 200 is 20, and 9% times 200 is 18. So that gives you your expected value. Then you're going to fill in the last column, and I've shown you one of those here. You take 78, which is the observed amount, times the expected amount, and you divide it by the expected amount. So 78 minus 82 squared divided by 82 is equal to 0.195, and you would do each one of these, and then you will get the sum. So the sum is 2.025. And when you leave that, what you're going to do is you're going to look at your rejection area. Now my rejection area is any number greater than 13.277. This is not in the rejection area, so I'm going to fail to reject my null hypothesis. And the answer, the way you interpret the decision, no, at the 1% significance level, there is not enough evidence to conclude that the distribution of responses differs from the claim or the claimed or expected distribution.